Hey everybody, this is May 13th, the 13th day of the May Leetcode challenge. Let's refresh the page for hit the like button, hit the subscribe button, and let's see what today's problem is. Remove K digits. Alright. Also join the Discord, hit up the website, Alchemist, and hit up all kind of things while you're at it. Remove K digits. Given a non-negative integer num represented as a string, remove k digits from the number so that the new number is the smallest possible. The length of the number is less than 10,002. That's an odd number, but okay. What's a strange even number? And will be greater than or less than k. The given num k does not contain any leading zero. Okay. So, um, this seemed to be like my first intuition is that this is going to be some variation of a greedy algorithm. What is the smallest number, right? Hmm. Let's take a look at some cases. So it is going to be greedy in some way, but we have to try to figure out the strategy and then try to prove it correct a little bit, which is easier said than done, obviously. But uh, But let's take a look. And then here you remove the one, and the number is 200. Note that the output must not contain leading zeros. Okay, so it does not contain leading zeros, but it's still, um, but this is the smallest. Oh, because if you remove one digit, oh, you remove, wow, there's a lot of edge cases on this one. I think that's the first thing that I noticed, and um, I'm gonna be a little bit worried on because I would imagine like you remove the two so that but then you get 1,000, which is obviously bigger than 200. But then you okay with leading zeros as long as you just don't point it out, which is weird, really weird way to think about this problem. Or but okay, I think the first way I would think about it is okay. So k is oh sorry, the number of digit will be 10,000, right? So it is two. So if you try to do so n is 10,000, and if you try to do n square algorithm, that's going to be too slow. Meaning if you take one, if you try to do some naive algorithm, which is what I was thinking of, where you okay remove one digit and then compare um, which digit to remove is the min, uh, but and then kind of do it iteratively. But that's not going to run fast enough because that's n square, right? So you definitely need something that's one digit at a time. I think the second thing to notice though is that I think I have some idea. I'm just thinking through this idea a little bit. The idea that I have is that um, you're only ever going to remove. Um, I mean, this is still a little bit brute forcey, so that's why I'm still thinking through it a little bit. But my brute force idea is that okay, you're only like given the same digit, like for example, digit one, given these two digits, you're always only going to remove one of them to make them smaller, right? Like there is some inherent ordering, and I'm trying to figure out what that ordering is because it doesn't make sense. Like, like if you have a, let me, oops, let me put this here, for example. Like if you, let's say you have a number with a lot of ones, uh, do we have to consider all ones? Or can we just, is it enough to consider one one, right? Oh no. Actually, maybe, I don't think that I could figure out the easy way around that one. And then the second thing I would, or an additional thing that I would think about is, in this case, you want to subtract 4, or you remove 4. Hmm. It's kind of a tricky problem to get right, where like, I suspect if this was a contest, I'd be lose that, but also have a couple of wrong answers with a couple of strategies. Um, but I think the first thing I would do is maybe think. I think what I do with these greedy solutions is that I try to come up with a strategy and then think through it, and then um, think through, well, other counter cases and stuff like that. And sometimes I miss the counter case, obviously, to be honest, but because it's hard. But another strategy I'm thinking of is maybe we remove the first digit that is bigger than the digit to the right, right? And why is that the case? Because when we remove that, that means, because when we move, given a digit, if the digit to the right is smaller than it, that means that we're essentially comparing two numbers, though not directly. One, for in this case, let's say you have this number, because if we remove the 3, we get this number, and then we move the 4, we get this number, right? So in a way, if we just take a number like this and then we move the first number that is bigger than the second number, then it should give us um, I think that should give us a pretty good place to start. The only other thing that is, I think that would probably be good enough for a lot of cases. The only other annoying thing for this problem is the leading zeros, and how to do that. Um, let's see. Can we deal with, because the thing with leading zeros is that the thing with leading zero is that um, I'm trying to think right now through the strategy of what does a leading zero mean, and the leading zero makes it so that you almost want to remove everything before the zero if it gives, like, because having leading zeros just let you remove additional digits for free, and that's what this does. But I think, and I'm also trying to split between that and this idea of taking advantage of what we already have been doing. For example, in this case, k is equal to 1. The idea of 0 means that, well, 1 is bigger than 0, so we can just use the same strategy, right? So, but then I'm already thinking through, well, what happens when you have, like, okay, this is not decreasing, but you have, like, this, and then 5 or something like that, something like that, and your k is equal to 5, so you remove 5 digits, so you definitely want to remove these 5, and obviously you remove this one first, and then it'll be 4, 0, and then so forth, and then maybe that still works. But I'm just trying to, I think, prove myself correct a little bit, at least not like a math. I mean, maybe ideally like a mathematical proof, but for me, just trying to convince myself that this is good enough. Um, like I don't like, this is not a video stream of me just be like, oh yeah, like me reading an answer to you and be like, okay, this is why. I want you to think, or I want you to, when you watch this, and what makes this series unique is that you see my thought process, you see me trying to like really convince myself of these greedy problems, and I hope that gives you insight as to like how someone might attack these problems and not just be like, oh yeah, do this thing, it's obvious, it's just greedy, duh, right? That's not how I prefer to think about it. And also in this case, I think my next question is, okay, well, if this is k equals 5, then obviously we want to remove these 5, and then we get all these like 6 or 7 digits for free. But let's try again with k is equal to 4, right? Well, what does 4 look like? Do we remove these 4, or do we remove these 4? Well, I think we remove these 4, so I think the same thing holds where we take the first, from the left going to the right, we take the first number that is bigger than its number to the right, and then just remove it, right? And I think that will give us the property that we want. And then in the end, we just remove leading zeros. And I think that would be okay. Yeah. And I think the second thing you may think about is, okay, now we have this strategy, right? And let's say I am convinced that it's correct. I'm still a little bit iffy, to be honest, if you ask me personally. Let's say you're really convinced that this is correct. Well, how do you solve this? Well, we just do a naive algorithm of going from left to right every time, like someone like, now, wow, k is bigger than 0. We move left the first number bigger than its right number, or like first number num sub I such that it is bigger than sub I plus 1, or something like that, right? So this is what we want to do, and that's your code. And then, but this, of course, would be n square algorithm, right? That we talked about even earlier, where if your code is something like, I don't, your input is something like this, and k is equal to n. I don't need to count, and you remove the last number one by one by one by one, then that's going to be n squared, right? You just sum up the series and you get n squared, and that's not going to be fast enough. At least given that the test case is actually good. I mean, if it's not, who knows, right? And also we probably have to consider, which I did in my little short convincing, that if this is equal, do we remove it? Well, let's take a look. Actually, I think that's a case we have to consider. So it's not something that I could just hand wave over, because I don't know that I'm convinced either way. But let's say we have 1, 1, 2, 2, 3, 2, right? Now let's say k is equal to 1, just because I think we can prove by induction, kind of, maybe not. Where do we remove the 3, or do we move one of the early 2s? Okay, so we will remove the 3, we just get a string of 2s. We will remove one of the last 2, then we get this, which is clearly not min. If we remove one of the early 2s, we also, the 3 moves up instead. No, I mean, well, not move up, but move up kind of. So we probably still want to remove the 3 first, so if they are equal digits, we wait until the end to remove them. So okay, so now that we fully fleshed out our strategy, like again, am I super convinced? I don't know, but I mean, I feel like I am okay enough to move on. I think if I was like by myself, maybe I would try to come up with more edge cases and stuff like this. But I think for now, I'm convinced-ish. If not, we'll see. Part of this experience is going to be learning as well. So let's do that. Well, yeah, so now we have this algorithm that we're n squared. So how can we do better? Well, we can notice that what happens after we remove this digit, right? Well, we remove this number, and what does that give us? Let's say we move to 5, right? What? Okay. So then this is your new problem. What does that give us? And well, now this is the same problem, but with k minus 3, right? And well, the prefix of the problem, the 1, 2, 3, 4, we already know that the no numbers that are bigger than the right, because the invariant is that if that's true, we would have already removed them, right? So now, what I would say is, now that we're still processing the 0 and we still have 3, well, now we just have to delete another number, and then delete another number, and so forth. And for me, that reminds me of the data structure, a stack. And so that's how I'm going to implement it with a stack, because we have the leftmost number, and yeah. And sorry for all the honking. What is going on down there? Maybe I'll edit it out, but that was kind of really what's going on. Okay, anyway. Yeah, so I'm going to implement that with a stack and then keep on popping as long as we have k, and also as long as the number that we're pushing in is smaller than the number to previous. So kind of equivalent. All right, that's kind of cool. And then we have to remember to remove leading zeros at the end, which normally when I'm coding or when I'm after, and you may notice that I don't code until I kind of formalize a bit more what I want to code, even if it's not complete. But yeah, and also in general, just because sometimes I forget, I would write something like remove leading zeros. But in this case, it is part of the test cases. You could also have, do something more TDD with putting a case with leading zeros so that it's obvious that you need to remove leading zeros, because if you don't, then it'll be a little bit sad. Let's just try 5. Yeah, and a good case actually, as I was looking at it, is that what happens if 6? So ideally, you don't remove this 0, you remove this 5, so then you get 2300, because everything else will be, you get for free because it's a leading 0. So that's yeah, let's go. Let's go. It's time to code. After talking about for about 18 minutes, it's time to code. But sometimes when you fresh out what your thought process is, it becomes way easier to code, and the coding is just typing in the solution, right? Ideally. Okay, let's go. So let's put stack as you go to this. Um, are there any leading zeros? The given number does not have leading zeros. Okay, so we don't have to worry about that case. And then now let's just for digit in num. If len of stack is equal to 0, or stack the item on top is bigger than digit or equal to, then stack dot, we just push it onto the stack, right? Yeah. Okay. Is that good? It is, but we actually want the inverse of this, because I think we always want to push this anyway, but we want to put the other case where while len for stack is bigger than 0, and the top of the stack is bigger than this or smaller than this digit. So the exact opposite. Then we want to do stack dot pop. Right. We just so yeah. So pretty. That's pretty much it, really. Okay, I mean, I know we have to remove the leading 0, but I just want to. I think we're okay with converting this back to a string, and then oh, no, yeah, okay. Oh, actually, I forgot to consider k, but yeah, and k is bigger than 0, and then for each digit pop, we want to remove 1 from k. Okay. Yeah, so let's run it real quick. Just, I think this is roughly right. Okay. Do I have my signs wrong? So the digit is bigger than. Oh yeah. So if the top of the stack is bigger than it, then okay. See, it's but that's why you do testing, right? That's okay. These are easy things to fix. Okay. See, now everything looks mostly okay, right? Actually, I mean, we knew about the leading 0, so we weren't going to. Yeah, I mean, we are going to fix it, obviously, because that's easy to do. But yeah, and then now we just, yeah, I'm just trying to think about what's a clean way to do it, because stack is in a list in Python, and removing from the font the list is annoying. So let's just keep track of, okay. Uh, leading leading 0 index equals 0, while stack leading 0 index is equal to 0, and leading 0 index is less than n, where n is the new n is equal to length of stack leading 0 index 1, and then now we just have to take the slice starting from the 0 index. Ah, well, if I were. I think also this is a char. That's why that this is a little, yeah, this is a char. So there is some confusion about types here, which is actually a little bit tricky. Okay, I guess we could just do this. Cool. Yeah, I think the only case that I might want to think about is just the 0 case, and just a case where, I don't know, the k is ridiculously big, I think. No, I guess it just has to be equal to, or it can be equal. Oh, yeah, that's right. That's the other case that I forgot about, which is why we test, which is that I actually had it up here. Yeah, this case, but I forgot about it. But we just forgot about it. This is why you test sometimes, and especially when you're not confident about your code. Um, and you'll see that we just don't remove because it doesn't go over because we have k left. So we have digits in the end that we don't remove. Why is this right? Oh, because what? Actually, so what I'm surprised about is that this is actually the right answer. I thought that this would actually give me the wrong. Oh, no, no, this is the wrong answer. Sorry, I was looking at the expected answer for some reason. I got a little bit mixed up. Okay, so because what I was doing is that not only when you get the right answer that you expect your right answer, but when I test before I implement my fix, I want to make sure that for these inputs, I get the correct wrong answer. And what I mean by that is that I know this is what I would expect my code to return, but if it suddenly gave me the right answer, then I have to really think about what my code is doing. So that's what I was a little, but I just misread it. So that's okay. So yeah, so now we just have to pop off the end of the stack as long as this is true. So as long as we have k for it. So while length of stack is greater than 0 and k is greater than 0, stack.pop k1. Okay, and I think because we didn't have this, we didn't run into an empty stack problem, but now we may have an empty stack problem, so we might have to think about it. But let's run it just to make sure that, and I think I'm going to be right in that. Yeah, there you go. So yeah, so now if n is equal to 0, just return 0. That's pretty much it, really. Yeah, the only thing that I was thinking about was maybe leading zeros for this one. But yeah, it seems okay. So am I confident enough to submit? Yeah, this feels a little sketchy. That's why sometimes I hesitate because sometimes these code have a smell to it. And this looks okay, but I am worried a little about like, okay, let me try this case. I think that's what I wanted. Like something really simple, really, just to make sure that we get that correct. Okay, if that's correct, then I think I have a little bit more confidence. Let's submit it and let's see. Okay, cool. Okay, right answer, accepted. That's pretty nice. Yeah, this is a long problem. Obviously, this video has been going on for 20 something minutes. Um, okay, so what is the complexity, right? The complexity is that we look at each digit at most once, we push and pop it once at most. So it's going to be O of n, also O of n space because we put everything on the stack. So that's a greedy solution, obviously. So that's there is. Um, in competitive programming, I feel like nowadays the meta is a lot toward these constructive slash greedy algorithms. So definitely practice it. You saw how I kind of thought through it. This is probably a reasonable competitive programming problem. For an interview, it's a little bit tricky and hard to say. These greedy problems are always, as you can see, annoying, but it's solvable. And also in an interview, keep in mind that you also have an interviewer to bounce ideas off. So in that sense, it's a little bit easier than solving it by yourself, but it's still a little tricky. And there's a lot of proofs that you have to prove to yourself correct, which I don't know if I can do per se, but it's definitely recommend that you practice these things because it, in theory, is easy enough to some interviewers to be able to give, and they're like, oh yeah, it's obvious, and it feels obvious to people. But for me, I have enough experience of getting bitten by greedy solutions that it for problems that aren't greedy, so that I'm a little bit hesitant about stuff like this. But otherwise, no, and it's an interesting problem, a cute problem. I dig it. I mean, and the components of this problem is something that I recommend in general. The stack is pretty cool. It's yeah, the stack is pretty cool. You know, it's a very basic data structure that comes up all over the place, and it's something that you should practice on. So even if you have a greedy solution, it's not over yet. You still have to make that optimization from n squared to O of n. So it's a good problem. It's a good practice. This is all I have for this problem, I think. Um, yeah, let me know what you think. Let me know how you did. This was kind of tricky for me. So hope the long runtime justifies it for you. Hit the like button, hit the like button, hit the subscribe button, and hit all the buttons. Leave a comment in the chat. Let me know how you did. Did you do any other way, or did you also did greedy this way? Cool. I will see y'all tomorrow. Bye bye.